Welcome to video 8.4b, more proving proportions from similar triangles. All right, so I've got two examples. Example 2, I'll mark it up as we go. Given that BD and CE are altitudes, so right away you're a right angle and you're a right angle. Prove that DF over EF equals CF over BF. And then after that, do this extra step. I added this to your notes just so you would have more practice with what to expect in the homework. Okay, so again, proportion. I first want to get triangles to be similar. So let's identify the triangles that I care about. So I've got a DF, I've got a DF, I've got an EF. Notice that the EF is in a different triangle. So we'll just dash that. I've got a CF, I've got a CF, and I've got a BF, and I've got a BF. So this is what I was talking about before. It could be within triangles or across triangles. So now my triangles will be this green one here. Then I'll just use a different color. I'll use black. In this triangle over here. And once I get those triangles similar, then I can get that, and then I can get that. Again, angle, the right angles, the vertical angles, angle is going to be the key to most of these problems. Okay, now I know what to do. Let's do it. So I'll start with this. BD and CE are altitudes. That was given. Based on that, I can get the right angles. Angle, I'll go CDF. I'll go this one first. Angle BEF and angle CDF are right angles. If altitude, then right angle, and then if right angles, then congruent. Angle BEF is congruent to angle CDF. If right angle, then congruent. That's one of my angles. I'll get the other angles by vertical angles. Angle EFB is congruent to angle DFC. If vertical angles, then congruent. That's my other angle. Then I'll get the triangles to be similar. Triangle, I'll go BEF. Is similar to triangle CDF. Angle similarity. Once I've got that, then I can get this proportion right here. DF over EF equals CF over BF. Again, I'll check my ordering. DF is the last two. EF is the last two. CF is first and last, BF is first and last, that matches. And then the new thing, if I wanted to get this, I didn't even mention that, you'd have to get that first. And that's what's going to be a little bit more confusing. So DF times BF equals CF times EF. Oh, I didn't give a reason for this. If similar, then corresponding sides proportional. In this one, the book's going to say the means extremes theorem. I'm just going to call it good old-fashioned cross multiply. Okay, so that's that for example 2. Let's move on now to example 3. Again, I'm trying to prove a proportion, so I'm going to get triangles similar, and then kind of use the converse of that definition. All right, I'll mark it up as we go. I've got triangles. Oh, these triangles are similar. The big triangles are similar. So I'll just outline it. So that big triangle is similar to that big triangle. They've got AD, so I've got an angle bisector here, and I've got an angle bisector over there. And I want to prove this. So again, I'm going to be looking at the lettering. I'll outline it in green. I've got an AD, I've got an AD, I've got an AB, I've got an AB. So I'm looking for that green triangle there. I'll do the other one in red. RW, RW, RS, RS. So now my goal is to get this green triangle similar to that red triangle. I was given the big triangle similar and some angle bisectors. Once again, I'm going to try to use angle. I've got no information whatsoever about sides. So let me see what my plan of attack will be. If these triangles are similar, then I know that that big angle A and that big angle R are congruent. Oh, if this is an angle bisector and this is an angle bisector, going way back to angle division. Okay, so I'll get this angle to be congruent to that angle, like divisions will be congruent. If the triangles were similar, this big angle is congruent to that big angle. So that's how I'm going to get my angle similarity for the small ones, and then I'll be able to branch out and do that proportion. Lot going on here. Let's write it down. Okay, so I'll start with this right here. So triangle ABC is similar to triangle RST. That was given. And based on that, I actually got two things to happen. So I got angle BAC congruent to angle SRT. I'll just start with that. If similar, then corresponding angles congruent. Okay, angles congruent, sides proportional. Then I'm going to list this stuff right here. AD bisects angle BAC. RW bisects angle SRT. That was given. And then based on this and this, I'm going to get these smaller angles to be congruent by like divisions of angles. So I'll get angle BAD to be congruent to angle SRW by our old friend angle division. Whew. All of that for that. And then I'll go back to this step here just to let you know step 1 is linking to step 5. I'll get angle B to be congruent to angle S. Again, if similar, then corresponding angles congruent. Then I'll get those smaller triangles to be similar. Triangle, whatever, I'll go BAD. BAD is similar to triangle SRW. That's going to be by angle similarity. And then once I get that, I can get that. AD over AB equals RW over RS. If similar, then corresponding sides proportional. And again, I just like to check my ordering really quick. So last two over first two, and then last two over first two. That makes sense. So there you have it. 2 more examples on proving proportions from similar triangles.